right, let's start with this question over here. All right, first thing we need to do, if we look over here, we need to first read the information that we've been given. So we're first going to start by reading the information given, and then we're going to look at the properties of each of the functions that we've been given in this particular question. All right, so first thing they say here is the graph of f of x is equal to ax squared plus q, and g of x is equal to 3 over x minus 1 has been given over here. And then it tells us that x is greater than 0, where x is greater than 0 are drawn below. All right, so first thing we need to do, I will zoom, there we go. Okay, first thing we need to do is we need to identify which two functions we've been given. What two functions have we been given, grade 10s? What two functions? Who can tell me? Or rather, I can ask what graphs. Good. Gift, one of them is a parabola. What about the other? And a hyperbola. Amazing. All right. So let's quickly look at the properties of each of these because we need to know these. Right. So if I remember effectively, and I hope I do, right? I know that the function of a parabola, f of x, is equal to ax squared plus q, tells us a couple of things about what we need to know about the function, right? Ax squared plus q, oh my goodness, plus q. All right, okay, so I'm just going to emphasize here as we go along. Sorry, let me just rewrite ax squared plus q. I'm going to emphasize as well that we do have another way to write out the function of a parabola, and it's not as common as the others, but we do see it. So sometimes we can use this. F of x is equal to a, open brackets, x minus d. I think they call it d, or well, at our school we call it r, so I'm going to call them r1 and x minus r2. Can I just get a general sense? Thumbs up. How many of you guys have seen the second one that I've just written? Thumbs up if you've seen it before. Thumbs down if you have not. Okay. Okay, great. Gifts has seen it. All right, let's talk about what actually happens in this particular type of question. Now, let's say, for instance, I give you guys a parabola, right? And my parabola looks like that, right? If I know that these 2 points over here are 2 and 0, and on this side, -2 and 0, and then I'm also told that there's another point over here at 1 and -3. 1 and -3. Okay, now this R1 and R2 is the intercept. It's the x-intercept of this graph. Okay, so if I want to figure out the graph without having to use the turning point, or the y value of the turning point, which sometimes we're not given, as you can see in this particular graph that I've given you here, we don't have the turning point. So I can't really use ax squared plus q. What I can do is I can take my 2 coordinates and I can put them into the formula. So my formula will end up looking like this. F of x is equal to a, open brackets. Now, because this is a function in x, so if I say to you guys, I've got x minus 3 is equal to 0, you would all tell me that x is equal to 3. Thumbs up. Does that make sense? Are we all in agreement there? Right? X is equal to 3. So when they've given me the point -2, what they're actually telling me is that x is equal to -2. So when I put it back into the bracket, I need to change the sign. So the sign over here will be x plus 2. Does that make sense? Same with this one over here. Over here, they're telling me that x is equal to 2. So when I put it back into the bracket, I need to rewrite it into the bracket as x minus 2. Yes? Thumbs up. Does that make sense? Okay, I'm doing the inverse operation. I hope everyone's with me there. All right, so what I'm going to then do is, instead of writing -2, I'm going to write x plus 2. And then over here, I've got positive 2, so I'm going to write x minus 2. Okay. Then I'm going to FOIL. I'm actually going to FOIL. So I'm going to get f of x is equal to a, open bracket, x squared, and then I'm going to get x squared minus 2x plus 2x minus 4. And I know that this is dots. So the two middle terms are going to cancel each other out. Minus 2x plus 2x minus 4. And then I know that negative 2x plus 2x will cancel out. So I will end up with f of x is equal to, open brackets, a, open brackets, x squared minus 4. All right. Thumbs up. Are we okay still? Everybody still with me? Yes? Okay, I'm going to do just one more quick example so that we don't get lost. Okay, so if I've got my function over here like this, and they give me these two values over here, and they must give me another point. So let's say, for instance, this point over here is 4, 0, and this point over here is negative 4 and 0. I know that I can go f of x is equal to a, open brackets, x minus r1, and x minus r2. And then I'm just going to go f of x is equal to a. And then because this is negative 4, when I put it back in my bracket, I'll put it in as x plus 4. So x plus 4. And because this is positive 4, it will go in as x minus 4. All right. And then I'll get f of x is equal to a, open brackets. This is dots. So I'm going to end up with x squared minus 16. All right. Are we okay here, grade 10s? Yes? Lovely. Okay, we've learned something new today, I hope. This is another way in which we can use our intercepts in order to find what we're looking for. But that's not the point. We've just learned of this other way now, and we can see if we can put it to use if they ever do give us an equation where we need it. Okay, so that's one of them. Okay, the normal one that we're used to is ax squared plus q, and we know that q is the y value of our turning point, right? That's the y value. We know that our turning point is always 0, and whatever q is, that'll be the turning point, because our turning point will be on our y-axis. All right. Other things we need to know, as always, remember to find the x-intercept. You make y equal to 0. In order to find the y-intercept, we make x equal to 0. And then please remember your domain and your range. Right, your domain, x is an element of all real numbers, and y is also an element of all real numbers, but y needs to be greater or equal to your turning point. If it's concave up, if it's a smiley face, then it needs to be greater than or equal to the turning point. But if it's a frowny face, then y must be less than or equal to q if it's frowning. All right, and those are the conditions of a parabola. Okay, these are the things that are going to come up again and again and again in a parabola, grade 10s. So these we must have ingrained to memory. We need to know these things before we head into any of the questions that we're looking at. All right, hello, Fortunate. Okay. All right, amazing. For those of you who've seen this before, you've got a bit of a leg up, because we actually teach it in grade 11, but then it's good to know in grade 10 because it really does help. Okay, let's talk about hyperbola. Now, I know that the function of a hyperbola, f of x, let's write that a little bit better, that's ugly. F of x is equal to a over x plus q. All right, and we know that our hyperbola gives us asymptotes. We know that we must have two asymptotes. We must have a vertical and a horizontal asymptote. Our vertical asymptote, which touches the x-axis, so the vertical one is x, where x is equal to 0. We have problems. And remember, guys, asymptotes are the dotted lines that are drawn. Okay, remember that. And then our horizontal asymptote is where y is equal to whatever the q value over here is, the vertical shift. That is our vertical asymptote. And or horizontal asymptote, and it will be written like that. It will be drawn dotted line. All right, next thing we need to know is that if a, this value over here for a, is a positive number, so if it's positive, then we will draw our two graphs in quadrants 1 and quadrant 3. And if a is less than 0, so if it's a negative number, we will draw our graphs in quadrants 2. Let's do that again. 2 and quadrant 4. All right. And then again, it's going to happen again and again, grade 10s. X-intercept, y is equal to 0. The only difference with this hyperbola is that we will not have a y-intercept. There is no y-intercept. And the reason why there's no y-intercept is because in order to find a y-intercept, I would need to make x equal to 0. But I know that because it's an asymptote, x cannot equal 0. My graph is not allowed to touch the point 0. So we do not have an x-intercept. Thumbs up. Does that make sense? Is everybody understanding what ma'am is saying there? Our hyperbola does not have an x-intercept in grade 10. It's unfortunate. You're going to jump over to grade 11 and they're going to completely change things. But for now, our hyperbola does not have an x-intercept. All right. Then we've got to remember the domain and the range. As always, the domain x is an element of all real numbers except x cannot equal 0. It's defined everywhere except at 0. And for our range, y is an element of all real numbers where y cannot equal whatever the q value is. That's what y cannot equal. Does anybody want to take a screenshot? I'm going to zoom out a little bit. If you need to take a screenshot, take it now. Okay, I'm just going to add in here where a is greater than 0, smiley face graph. Where a is less than 0, frowny face graph. You've got 5 seconds to take a screenshot. 4, 3, 2, 1. All right, we're all good. Okay, let's look at the question now. The question says here, we've been given the graphs of f of x is equal to ax squared plus q. So we know that we've got a parabola. And g of x is equal to 3 over x minus 1. Right, before we even go anywhere, does anybody want to tell us a couple of things? Anybody want to tell us anything? What do we note? If we look at this graph over here, let's look at the graph, Narisha. Let's look at the graph of our hyperbola. What can we tell just by looking at g of x is equal to 3 over x minus 1? Great. Good, Sanele. We know that a is greater than 0, so our graph needs to be drawn in quadrant 1 and quadrant 3. But now, look at the restriction that they've given us. They've told us that for this graph, they've only drawn where x is greater than 0. So they've only drawn half of it. They've only drawn that part of my hyperbola. They haven't drawn the other side of my hyperbola. They've drawn one side. So it's quite important that we understand this distinction. If you've never seen this before, please highlight it, grade 10s. It happens quite often. Please make sure that you highlight it, that it is a hyperbola, but they've only given us one side of the hyperbola. It does not mean that this is an exponential graph. Okay. All right. What else do we know? What else do we see, guys? Look at the graph. A is greater than 0, so quadrants 1 and 3. We also know that for hyperbola, we have an asymptote. What are my two asymptotes? My vertical asymptote, I will start off with the nice and easy one. My vertical asymptote, x is equal to 0. So I know that over here along the y-axis, there's my first asymptote. Where's my other asymptote, guys? That's it, where y is equal to -1. Good. My horizontal asymptote is where y is equal to -1. So I can go into my drawing. There, they've drawn the line in for me. So I know that this dotted line here is where y is equal to -1. All right, great. We figured out so many things before we even get started on this, which is lovely. All right, let's read the rest of the information. It says A is the x-intercept and the point of intersection of both graphs. Good. So we know somewhere we need to go find an x-intercept. And we know when we want to find an x-intercept, y must equal 0. So the only graph we're going to be able to do that in is in the hyperbola, because our parabola doesn't have any information for us. Our parabola just says ax squared plus q. We can't really make y 0. We won't be able to solve for anything. So the way we're going to be able to find the point for A is if we go into the formula for our hyperbola and we make x, or we make y equal to 0. Does that make sense? Thumbs up. Yes? Right. So as we're reading, we're putting all the bits and pieces together as we go. Wherever we see x-intercept, y must equal 0. All right. The point of intersection is also very important. We'll get to that in just a little bit. Then they tell us that the point B, 0, 9, is the turning point of f. What does that tell us? Who can tell me, what does this 0, 9 being the turning point of my parabola of the f have to do with my equation of the parabola? What does that tell us? That's it, Didi Malo, lovely. What it tells us is that Q is equal to 9. Because if we look at the things that we had, here we go, Q is the y value of the turning point. So we know that if 0, 9 is our turning point, that means Q in our graph is equal to 9. All right. Everybody okay with that? Let me ask you before I continue. What do we know about A specifically? We don't know what number it is, but what do we know it's supposed to be? What kind of number should we get for A? Should it be a positive number or a negative number? Look at your graph, Sanele. Is it concave up? Is it smiling at us? Or is it frowning at us? It's a negative number. That's it. It should be a negative number because my graph is facing downward. So I need to make sure that whenever I do calculate for A, the answer I get out needs to be negative. So we know that it needs to be negative whenever it is that we calculate. Look, I haven't looked at a single question, grade 10s, but look at how much information I've been able to get out of this. This is a lot of information. All right, so reading the information that we have, very, very important. Okay, shall we have a look at the questions? Let's start with the easy questions. It says here, write down the range of f, the domain of G, and then it says the equations of the horizontal asymptote of G. You've already done it. We've already done it because we've analyzed what we have. Okay, right? And then it says the values of x such that f is decreasing. We'll chat about number 3.1.4 in just a little bit. Give me a thumbs up. Are we able to answer point 1, point 2, and point 3 all our own? Can I give you guys some time to look at those? Okay, remember when they say the range of f, they're talking about the function of the graph f. So f of x, which is our parabola. And when they say g, they mean g of x, which is our hyperbola. So I'm going to give you guys, not that long, 3 minutes. This is very, very easy. Take it away, pop an emoji on the screen when you're ready. Okay, amazing. I'm seeing people are done. Can we get started on these questions? They're quite easy. All right, let's look at 3.1.1. It says we want the range of f. Now, the range is the y values of f. So we know that because it's concave down or because it's frowning, we know that y must be an element of all real numbers, but then y must be less than or equal to the y value of my turning point, Q. Okay, somebody's saying, can ma'am explain how we find the equation of the horizontal and vertical asymptote? All right, Lerato, I'm happy to do that. Good. The domain of G is going to be a little different gift in that X is an element of all real numbers, but there's a specific value that X cannot be. X cannot be what? If you look at my parabola, X cannot be 0, that's it. So I have to say X is an element of all real numbers, but X cannot equal 0. All right. All right. Didimalo, when you say is it, do you mean why is it less than? Yes, is that, oh, okay, why is it less than? All right, let's talk about it. I don't mind. We've got time today, guys. I'm very happy that we're all here together. We've got some time. All right, so if I drew you guys a parabola, I'm going to draw you guys a random parabola. This is my x coordinate, or this is my x-axis, and this is my y-axis, negative y, negative x. Do we all agree that because we put these arrows, let me just redraw it really quickly, because I want to make it a bit fat so that the idea gets across. Do we all agree that my graph will continue going in that direction, and it will continue going in that direction forever and ever and ever? Yes, it goes to positive infinity, all the way, or from negative infinity all the way to positive infinity in all directions, right? None of those numbers are not included. So my domain of the function of a parabola is X is an element of all real numbers. Thumbs up. We good? Right? Everybody's okay with that. It will continue going in every direction. However, have a look at your Y values. Let's look at the range. Now, if I look at this, because it's a smiley face parabola, I know that my graph will continue going up in that direction forever, right? Will it continue going down forever? Yes or no? No, it won't, right? Because at some point, it turns because of the turning point. We're in agreement, right? It turns because of the turning point, and then it goes back up. So my Y values, my range, needs to be, it's an element of all real numbers, but my Y, because it's smiling, all my values can only be greater than, or equal to the turning point, which is the Q value. Does that make sense, grade 10s? If I drew it in the other direction, let's say we drew it facing down, right? My X values do not change. They're going to keep going in that direction forever and in that direction forever. They won't change. But I now know that my Y values will keep going down, but there's a point where my Y values can't go up anymore, and that is at the turning point. So when my graph is concave down, or when it's frowning, then I need to say that my Y values need to be less than or equal to the Y value of the turning point. All right, does that make sense? I'm so happy that like the lights are now on, right? Okay, amazing. All right, so when we look at the range, how do we know whether we put less than or equal to or greater than and equal to? It's because of the fact that my parabola, it comes down, 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 and then it turns and then it goes back up. Or if it's facing down, it will come up, 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 and then at the turning point, it doesn't go up anymore. It starts coming back down. Okay. All right. Amazing. Guys, I'm just happy that you guys are on the same page and the maths is now mathsing. You know what I mean? All right. And then I remember somebody asking a question about asymptotes. Let me just remember. Let me go see. Ma'am, can you please explain how we find the equation for the horizontal and vertical asymptotes? Absolutely. Okay. So if we look at our function, let's look at this function of our hyperbola. Right. I know that if I were to give you, let's just take this part over here. Right. I'm just going to write this without my vertical asymptote. G of x, and let me write y rather. Y is equal to 3 over x. X is going to be problematic when it's which number? Which number makes x problematic? Hey guys, which value can x not be? Good, it can't be 0, right? Because if I get 3 over 0, this is an undefined function. It's undefined. I won't get an answer for it, right? So I know that x cannot equal 0. That's how we know that one of our asymptotes is x cannot equal 0. X is equal to 0. Now, if I go onto my Cartesian plane, and I go to the point where x is equal to 0, x is equal to 0 there. Which means my whole y-axis is the point where x is equal to 0. Are we all in agreement? Do we agree? Because it's the y-axis, it's the y-intercepts. Everywhere where we have a y-intercept, x is equal to 0. So because we draw it vertically, that's why it's called the vertical asymptote. Okay. Now, if we go ahead and we make y equal to 0 in this equation, right? If I make y equal to 0 in this equation that we've got over here, I'm going to get 0 is equal to 3 over x. Now, if I solve for x, I'm going to multiply both sides by x times x times x. Those two will cancel each other out. And then over here, I'm going to get x times 0. X times 0 is going to give me 0 is equal to 3. Truth? Is that a true statement? True? Nope. X is 0 is not equal to 3. 0 is not equal to 3. So when we have a function that sits just like this, we know that x cannot equal 0 and y can also not equal 0, right? But I know that when I add -1, what -1 does is it takes my whole graph, my hyperbola, and it moves it. It takes the whole graph and it moves it down by 1. Are we in agreement there? Yes? Thumbs up? Right. It takes the whole graph and it moves it down by 1. So now my y value, the part where y was 0, will now be problematic where y is equal to -1. Therefore, y cannot equal -1. All right. Hello, Abu. Abu completely forgot that class starts at 5:30, which is okay. All right. I just need to make sure everybody's with me. Are we all okay with the vertical and the horizontal asymptotes of a hyperbola and why those values are particularly problematic? Okay. All right. I'm glad. I'm very, very happy. Lerato, that tells me ma'am needs to explain something again. Is there something else that I can explain a little bit better? I'm happy to explain again. Okay. Don't shy away from asking questions. That's why I'm here, Lerato. I don't want to confuse anybody or leave anybody away. You know what, Gift? It's perfectly fine, because if you understand 100%, the next questions are much easier. All right, Lerato, pick up your calculator for me, my darling, and punch into your calculator 3 divided by 0. Tell me what your calculator says. In fact, everybody who's not sure, tell me what your calculator says. 3 divided by 0, it gives us a math error, right? Because if I have 3 sweets, yes, if I have 3 sweets and I divide them by nothing, what am I actually trying to say? Like 3 divided by nothing doesn't make sense. You get what I mean? Okay, it doesn't mean I've got nothing, Abu. I still have 3, but I can't divide 3 by nothing. What does that even mean? So when x is equal to 0, we have a problem. So we cannot allow x to be 0. X cannot equal 0. Otherwise, we don't have a function. Does that make sense, Lerato? I hope I've explained. I've explained that okay. All right. So because of the nature of mathematics, anything divided by 0 cannot be, like, it just doesn't exist. It is undefined. So we know that we have an asymptote. We call it an asymptote at the point where x cannot equal 0. Yes, my darling, I do see your hand. Would you like to unmute and ask another question? Or was that you just agreeing with what we're saying? Are we all good? All right, amazing. Excellent. Okay, so that was just ma'am's 30 minutes of explanation, which are very important because now we've got we've got a bit of context into what we're doing. All right. So now it says it wants the equation of the horizontal asymptote of G. Horizontal asymptote is the asymptote that's going to cut my y-axis. So I'm looking for my y asymptote, which means my y asymptote. Now, guys, I want you to be careful. Don't just say y cannot equal to 1, or -1. That's not what they're asking. What they're asking for is the equation. So you must write that my asymptote sits at the point y is equal to -1. Make sure you get that right. The only part where we cancel out that it cannot equal to -1 is in the range. Okay, am I making sense? Thumbs up. The equation should just say y is equal to, because it's an equation. Only when we write down the range of G, then do we say y is not equal to -1. All right. Okay, let's continue here. So it says here, in 3.1.4, the question says, write down the values of x such that f is decreasing. All right, let's go ahead and look at our graph. Now, guys, whenever we read anything in mathematics, because we start with the smaller numbers, and we work our way to the bigger numbers. When we read our graphs, so when we interpret our graphs, we always interpret them from left to right, from the negative x to the positive x. Even if we were looking at our y values, we would look from the negative y going up towards positive y. All right, that's just the way, the nature in which we read these things. Okay, so when this particular question says, write down the values of x such that f is decreasing, let's go and trace f. F is my parabola. Now, if I look at my parabola, if I'm going to read it from this side, going up, is that decreasing or increasing? What's happening here? You can even use thumbs. Are we going up or down? We're going up, right? It's increasing, 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 increasing until I get to my turning point. What happens when I get to my turning point? My graph starts decreasing. Exactly. My graph starts decreasing. So when this question says we want to determine the values for x such that f is decreasing, f starts decreasing where x is how much? How much is x at that point there? X is equal to what over here? No, that's the y value, guys. That's the y value. The 9 is the y value. That's it, Sanele. It's at 0. That's it. My x value, because they want the value of x, I need to then say in this question that f starts decreasing where x gets greater than 0. Thumbs up. Does that make sense? Are we all good? I'm so glad. I'm so happy. All right. So when they say decreasing or increasing, go look at the value where your graph starts turning from going up to going down. Okay. All right. Now it says, let's look at 3.2. Determine the values of A and Q. We already know what Q is. Agreed? We know what Q is. We figured it out before we even started the question. Didimalo told us. Didimalo said, because the turning point of our parabola is 0, 9, that means Q is equal to 9. So you've already given yourself one nice point. Q is equal to 9. There. We've already got 1 point. The thing we now need to go figure out is the A value. Okay. Is our A value. Now, we're going to have a bit of a situation in figuring out A. Okay. The problem we're going to have is that we need another point on our graph of the parabola, not the turning point. We've already used the turning point to establish that Q is 9. We need another point on our parabola that can help us find this point. Good, Abu. So we need to find an x-intercept. Right. One of my x-intercepts is that one. Where's the other one? At which point, guys? At A. Good. It's at A. So we need to figure out the point A. Okay, how are we going to find the point A? Let's go back to the information and read as to what it said. Let's go back up. In the information, it said to us, A is the what? It is the x-intercept and the point of intersection of both graphs, right? So when you guys say make y equals 0, which graph are we going to use? Are we going to use the parabola or are we going to use the hyperbola? That's it, Lerato. Good. It's not an exponential, Abu. It's a hyperbola. Oh, yeah, you missed that part. Good. We can't use the parabola. It doesn't give us enough information. So let's go and use our hyperbola to find that point there. Right. So let's write it out. We've got g of x is equal to 3 over x minus 1. And we know that we want to find the x-intercept. So x-int, y equals 0. And we know that this whole g of x, we can replace the whole of g of x with y. All right. So I want you guys to go ahead and replace this g of x with 0 and determine x for me, please. I'm going to give you guys 2 minutes. Okay. Just to make it a little bit easier. Okay, I'm going to replace g of x with y, and your job is to replace y with 0 in this equation and then solve for x. Drop your answer. Narisha's already done. Okay. Okay, never mind. I thought this was going to take forever, but people already have answers for me, so I go. Okay, all right, let's see what we've done here. Okay, so we're going to take y and replace it with 0. So we'll get 0 equals 3 over x minus 1. Next thing I'm going to do is I'm going to take negative 1 over to the other side, and it's going to become positive 1. So I'll have 1 is equal to 3 over x. And then I know that I want x out of the denominator, so I'm going to multiply this side by x and multiply that side by x. Those two will cancel each other out. X times 1 will just give me x is equal to, and then on this side, we just have 3 left. Beautiful. So I know that x is equal to 3. So I now know that my x value here is 3. What is my y value at A? What is the y value there? Good. The y value, it's an x-intercept, y is equal to 0. Okay, lovely. Now that we've got this other point, we can go and sub it into the equation of f of x. Okay, so I now know I've got f of x is equal to ax squared. I know what q is. Q is plus 9. So now what I'm going to do is I'm going to sub in 0.30. That's your job. So what we're going to do, we're going to replace x with 0, and we're going to, we're going to replace x with 3, and we're going to replace y with 0 in this equation. Solve for A for me, please, grade 10s. Wikanya's already done. Abu's already done. Okay, let's give everybody else a chance. We'll give everybody else a minute or two. Kanyo, is that a whoa, what just happened? Or ma'am, wait, help me. Okay, what's going on? How can I help you? Are you done? Oh, okay, amazing. All right, just quick math, guys, quick math. All right, so I'm going to replace f of x with 0. So I'm going to get 0 equals a, and then I'm going to replace 3 with, x with 3. So I'm going to get 3 squared plus 9. Now I'm solving for a, so I'm going to take this plus 9 over to the other side, and I'm going to get negative 9 is equal to 3 squared will give me 9. 9 times a is 9a. And then to solve for a, I'm just going to divide both sides by 9, divide by 9, divide by 9. Therefore, a must equal negative 1. And that checks out. Remember at the very beginning, we said that our graph, our parabola, is concave down. We said that it's concave down. It's frowning. And whatever answer we should get for A should be negative. If we had gotten a positive answer, then you should have been like, whoa, I did something wrong. Let me look at it again. But we know because our graph is facing down, whatever answer we should get for A should be negative. Does that make sense, grade 10s? Yes, thumbs up. Are we all good? Amazing. I hope we are seeing the importance of 100% knowing the properties of our functions. We need to know what we're doing and the properties of each of the functions in order to effectively answer the questions. All right. Okay, so we've determined Q and we've determined A. Well done, grade 10s. You've got yourself a free form, another 4 marks. Okay. All right, let's look at question 3.3. Okay, because it's going to get a little bit techier, but we need to understand exactly what it is that we're doing in this instance. Sorry, I'm just going to write the answers here really quickly. Q is equal to 9 and A is equal to -1. All right, so in this next question here, it says if H of X, so they're giving us a new graph because at the moment we've got F and we've got G. They're giving us a new graph. If H of X is equal to negative F of X minus 3, write down the equation of H. Thumbs up. How many of us know what to do? Thumbs down if you are like, ma'am, why would you do this to us? What kind of question does this help me? Okay, all right. Okay, let's talk about this. And I'm going to use another example before we get into it. All right. So let me say I give you guys the graph of, oh, what did I just do? I don't know what I did there. Okay, I'm going to give you guys an easy graph. I'm quickly going to draw it. It's going to be an easy graph, right? So if I give you guys f of x is equal to x squared minus 4, what this tells us is that our a value is actually 1 because it's just ax squared, which is 1x squared minus 4. So if I were to plot this on my graph, I know that if I factorize, I would factorize and I would get dots, right? I would get dots. So I would end up with f of x is equal to, f of x is equal to, open 2 brackets, it's dots or difference of 2 squares. So I would get x minus 2 and I would get x plus 2. Right, so I know that the graph or the x-intercept of my graph would be where x is equal to 2 and where x is equal to -2. Thumbs up. Are you guys with me there? Yes? Everyone okay there? Good. So I know that my graph will cross at -2 and cross at 2. I also know that -4 would be my turning point. So my turning point would be at -4. And this checks out because if I just have x squared, that means my a is positive. It's +1. So my graph should be smiley. My graph should be smiley. Okay. Now, let's say I do this. If I do this, if I just take this graph and I put a negative there and I put a positive there, what's going to happen to my graph? It's going to reflect, right? Yes, and Gift, I agree when you're like thumbs down. It's just going to become, it's going to flip, right? Let's look at what ma'am did again. I can do it again. What I've done is I've taken this and I've gone negative and I've multiplied this whole equation. Sorry, that there was a negative there. I've multiplied this whole equation by a negative. So now if I distribute this negative in, I get, it's no longer f of x, let's call it g of x is equal to -x squared plus 4. So now my graph, the turning point of my graph is up there. And now it frowns. It frowns. Thumbs up. Are we in agreement there? Is everybody okay with this idea? Awesome. Awesome. Because I've added a negative, everything inside my graph has now reflected. It's flipped. It's reversed, basically. So now let's go to this question that we're looking at over here. they tell us that if the new function h of x, let me choose a different color, I want purple. All right, if the new function h of x is when we take f of x and we minus it, what's going to happen to that function that we've got over there for f of x? It's concave down now, but if we add this minus, if we multiply it by minus, what's going to happen to my graph? It's going to become concave up. It's going to flip. Are we in agreement? I hope everybody's with me here. Amazing. Good. So now we know that everything in my graph is just going to become opposite. Now I'm going to remind us that f of x was equal to, we figured out that our a value was -1. So we would have -1x squared, and our q is +9. Now, if I take my equation and I add a negative, it's going to be negative f of x is equal to negative, put that whole thing into brackets, -1x squared +9. And then we're going to distribute this new negative that they've given us. So now my whole graph is going to flip. So my turning point, instead of being at 9, will be at -9. It will look like that. All good? Thumbs up? Yes? Are we all good? Are we understanding where ma'am's coming from? Amazing stuff. Okay, good. We're not done. We're not done. We now know that our graph has flipped. So if we distribute that negative, we will get h of x is equal to, a negative and a negative will give me a positive x squared, and a negative and a positive will give me -9. And that reflects in the new graph that ma'am has drawn. But they also want us to go here and to -3. So I'm going to go into this equation that I've just written. I've got x squared -9, and then I'm going to -3. What does my new equation then look like? It's just going to be h of x is equal to x squared -9 -3 will give me -12. All right, so my whole graph, just exactly the way it is, has just been moved down 3 values. Yes, it's just been shifted down by 3. Okay, thumbs up. Are we okay still? I know it's a complicated concept. How 12? All right, so Didimalo, do you agree with me that our new function is x squared -9? If I flip the graph, if I take this minus and I implement it, it becomes negative. Everything changes from negative to positive. Does that make sense? Good. Now they're telling us that we must take f of x. After we've minused it, after we've inverted it, we must -3 from it. That's what they're telling us. But this is our new graph, and then we just -3. Add like terms. Just add like terms. So h of x will just be x squared -9 -3. All right. That's it. And that becomes -12. All right. Okay. If you are struggling with these kinds of questions, these are the types of questions we're going to be looking at the boot camp on Saturday. So I really hope you guys will be able to join us. When ma'am was saying that we're doing the easy questions first, those were questions like 3.1.1, 0.2, and 0.4, which is actually a very easy question. In the lesson that we will have on Saturday, this coming Saturday, we'll be looking at how to interpret questions like these. Okay. And we'll do it in a little bit more detail. So I hope you guys can join us just so you can understand a little bit more. Those of you who are already joining me, lovely. I really appreciate that you guys have. And I hope that more of you guys can join us so that we can focus on these kinds of questions. All right. Now it says it wants the coordinates. Let's look at the next question. Sorry, we figured out that h of x is equal to x squared -12. Now it says it wants the coordinates of the turning point of h. Now let's go back to our equations. Okay, we remember that the turning point is the Q value, and it's always 0 and whatever the Q value is. All right, so the coordinates of the turning point of our new graph, who can tell me what will the new coordinates of the turning point be? That's it, not just -12. We want a coordinate. Remember, guys, a coordinate must look like this. There must be a colon, there must be a bracket, a colon. That's it. We need to go 0 and -12. All right. Jaden, let me just address your question really quickly. Let me see. I will see what I can do, Jaden. It's a bit difficult for me because I do it on OneNote, but I'll see if I can send, I know exactly where I got this paper, so I'll see if I can send this exact paper and the memo for this paper so that you can have a look. Does that help? Okay, lovely. All right, so we want the coordinates of that. All right. Okay, so we're going to be looking at interpreting questions a little bit more on Saturday, but I hope that we've understood this question. How confident are we feeling? Thumbs up if we're feeling a little bit better about this. Yeah, are we doing, is it okay-ish? Okay, the more we get it, it's okay, Kanyo. It's a process. It really is a process. It takes a bit of time. All right, we're going to skip the rest of it because it's quite, these are quite interpretive questions, and I don't really want us to do this. I want us to focus on the basics. So let's move on to the next question. I want us to look at what we've been given over here. All right, let's read the information we've been given. We notice, we notice quite often that if we read the information we've been given, then it makes it a lot easier for us to understand where we are going. All right, so let's start by reading the information. The information says here, the sketch below shows the graph of f of x is equal to a over x plus q, and g of x is equal to negative x minus 2. What two graphs do we have, grade 10s? What two graphs do we have? The first one is a what and a what? Good, a straight line, and it's not a parabola. Parabola would be something, it would be x squared, that's it. Parabola would be x squared. This is over x, so this is a hyperbola. It's actually the same as the one that we were doing before. It's the same as this one. It's the same as 3 over x minus 1, except in this case, they haven't given us the values. All right, okay. Let's keep going. Now it says, the graph of f has a horizontal asymptote. What is the horizontal asymptote again? Is it the x or the y? Is it the x or the y asymptote that they've given us? It is. No, it's the x. And I know that it's a bit confusing, but let me show you how we know which one it is. Okay, go and look for the dotted line. We know that asymptotes are always dotted lines. If you go and you look at our dotted line doesn't cut the x-axis at all, does it? No, it doesn't cut the x-axis. It cuts the y-axis. Therefore, it is the y asymptote. Y is equal to negative 2. Does that make sense? Okay, our x asymptote will cut the x-axis there. It cuts the x-axis over there. All right, so if it cuts the y-axis, it is the y asymptote. If it cuts the x-axis, it is the x asymptote. Make sense? Easy enough? No issues there. All right, amazing. Okay, so now we know that our horizontal asymptote is at the point negative 2. Which value is that? Let's go to our actual value. Let's go to our actual graphs over here that we've been given. Which value is the y asymptote in this function that we have over here? F of x is equal to a over x plus q. Which one of those represents the y asymptote? The a, the x, the q, which one is it? That's it, short stuff. Amazing, it's the q. So we already know before we even look at the question that our Q value is -2. All right, we know this, it's -2. Okay, then they tell us that the graphs of F and G intersect at P and Q. And I'm going to explain intersections in just a little bit. All right. Okay, we're going to note that my graphs, my hyperbola is drawn in quadrant 2 and quadrant 4. What does that tell me about A? What does that tell me about my A value? Good, Narisha. My A value should be negative. Because my hyperbola has been drawn in quadrants 2 and 4, my A value must come out negative. Okay. Do we see how much we can figure out before we even get started on anything? There's so much that we can figure out. Right. Let me show you something. Look at question 4.1.1. Just read 4.1.1. I'll zoom in for you guys. What does 4.1.1 say? Write down the value of Q. Did we not just find Q? Before we even looked at the questions, we already knew what Q was because we knew how to interpret the graphs. So learning how to interpret the graph really helps us to answer the question. You're answering the questions. It's like you're writing the memo in your head before you even look at the questions. Okay, so let's write down the value of Q. We know that Q is equal to -2. Wow, easy marks, great. You know what I mean? Q is equal to -2. How nice is that? Before you even know how to, before you even know what the questions are, okay, before you even know what the questions are, you've already answered them. I'm not lying. Look, guys, we found the questions ourselves. We look at the answers ourselves already. Okay. All right. Okay. All right. Now let's look at 4.1.2. It says, the point -1 and 1 lies on F. Calculate the value of A. Now, let's put these two things together. If we go to our graph, we know that A is part of the hyperbola. Right? It's okay, guys. We know that A is part of our hyperbola. Let's rewrite the equation of our hyperbola. We know we've got f of x. We know the q value. So I can write f of x is equal to a over x, and my q value is -2. Are we still together? Are we all good? Thumbs. Amazing. Okay, so now they tell us that they've given us a point on the hyperbola. It's on the hyperbola. So what I'm going to do is I'm going to sub in this value. I'm going to sub in the point -1 and 1. Okay, this first value over here is my x value, and the 1 is my y value. So I'm going to go into this equation and I'm going to sub in. I know that my f of x stands for y, so I'm going to sub in my y value as 1, and I'm going to sub my x value in as -1. Let's see what happens. So f of x is my y, so I'm going to sub it in as 1 is equal to a over my x value will be -1 minus 2. What am I solving for? The only thing left for me to solve for is a. Can you guys solve for a for me? Come on, quick math. Move some things around, solve for a for me again. And remember, guys, we've established that a must be a negative number. So if you don't get a negative number, we've done something fishy. Okay, give me an answer in the chat when you're ready. That's it. Oh, Theo, a cannot be a positive number. It needs to be negative because our hyperbola is drawn in the second and in the fourth quadrant. Okay, let's do some quick math. I'm going to take -2, take it over the rainbow. Sorry, when I teach my kids, I call it over the rainbow when I teach my grade 8s. So take it to the other side and it becomes plus 2. So I'm going to get 1 plus 2, which will give me 3, is equal to a over negative 1. To get rid of the negative 1, I will multiply both sides by minus 1. Those two will cancel each other out. Therefore, a is equal to negative 3. All right. Okay. If you are struggling with getting the answer to this question, then this is an algebra problem. This is not a functions problem. It's an algebra problem. Okay. All right. So it says here, calculate the value of a. We've just done so. We know that a is equal to negative 3. So let's do ourselves a favor. Let's actually go and rewrite the actual equation of f of x. Let's write it out in full. We know what a is. We know what q is. So I'm going to write in here, f of x is equal to negative 3 over x minus 2. I've got both of those. All right. Before we continue, let's talk about the asymptotes. Let's talk about the asymptotes. What are my two asymptotes here? I have a vertical asymptote and I have a horizontal asymptote. Good. Tell me, Sanele, when you say negative 2, what asymptote is that? Is it the vertical or the horizontal asymptote, my negative 2? I just want to make sure we're all on the same. Good. Yes, yes, Sanele. Good. It's the horizontal one because look at it. It's sitting like this. It's horizontal. So yeah, so we know that our horizontal asymptote crosses the y-axis. So our horizontal asymptote is the y-asymptote. And we know that our vertical asymptote will be our x asymptote. And we know that x cannot equal 0. Otherwise, our function is undefined. All right. Okay, that's as much information as we have for now. Let's continue with the question. The question says, determine the x coordinates of P and Q. All right, let's talk about this. P and Q, in the write-up where they gave us, they said F and G intersect at P and Q. They intersect at P and Q. Now, let's have a look at our functions or at both of our graphs at each of these points. Now, I know that P is over here and Q is over here. Both of my graphs cut that point. So I know that if I use my straight line graph to find this point, I'm going to find it. If I knew what my x value was, I would be able to find the x and the y value using my straight line graph. And over here, if I knew what my x value was, I'd be able to find my y value using my straight line graph. Does that make sense? Thumbs up? Yes? I can use my straight line graph at both of those points and I would find an answer. But also, if I used my hyperbola, at that point, I would also be able to find my x and my y values. And if I used my hyperbola at this point, I would also be able to find my x and my y value. Thumbs up? Yes? Make sense? I can use either of those graphs. Both of them will give me the same answer. Both of them will give me the same answer at those points. So what this tells me is that at the point P and Q, my graph of F must equal my graph of G. They must be equal because they give me the same value. Both of them must be equal to each other. So basically what this question wants, when it says determine the x coordinates of P and Q, what they want you to do is they want you to take f of x. They want us to take f of x and make it equal to g of x. So if you're taking notes, I want you to write this down. Okay, somewhere in brackets, right there. Whenever we see the word point of intersection, basically what they want you to do is to take f of x, even if it's not called f of x, just write it as f of x is equal and make it equal to g of x. Okay, and then highlight it with a little bit squiggy, 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 like that. Whenever we see the words point of intersection, what they're saying is take your two graphs and make them equal to each other. Let's see what that looks like. Now, I know that f of x is my hyperbola, so I'm going to take this side. -3 over x minus 2. I'm going to go -3 over x minus 2 is equal to, and then I'm going to go and find g of x. They've given me g of x. They've told me that g of x is equal to -x minus 2. So -3 over x minus 2 is equal to -x minus 2. Okay, and now we've got an equation with just x's in it. So we now need to do funky algebra. We need to do some good algebra to figure out what x is. Okay, first thing I always do is I move everything over to one side. Okay, it will help me a lot. I like it better when it's like that. All right, I'm going to take -x over to the other side, -2 over to the other side. I'm going to get -3 over x minus 2 plus x plus 2 equals 0. The 2's will cancel each other out. -2 plus 2 is 0. So technically what I have left is I've got -3 over x plus x is equal to 0. Okay, I have an x in my denominator. So I'm going to have to find an LCD. So I'm going to take x and put it over 1. What's my LCD, grade 10s? My LCD is x. Good, my LCD is x. So over here, I don't have to do anything. I'm going to multiply here by x, and I'm going to multiply over here by x. All right. And then I'm going to end up with -3 over x plus x squared over x is equal to 0. Now, remember the nice thing about equations? As soon as my equations have the same denominator, I can just drop it. I don't really need it anymore. I don't really need my denominator anymore. So I've just got -3 plus x squared equals 0. Okay, I'm going to rearrange this. Is that okay? I'm just going to put the x squared first. Otherwise, my OCD kicks in. I can't do it. I'm going to write this as x squared minus 3 is equal to 0. Okay, and then we need to solve for x. This is a quadratic. So technically, what we're looking at is dots. I know it doesn't look like dots, but Abu's answer is spot on. His answer is 100% correct. Okay, his answer is spot on. It's actually dots. What I'm going to do is I'm going to move that -3 over to the other side. I'm going to get x squared is equal to 3. And then I'm going to take the square root of both of these answers. All right, square root of both sides. Therefore, x must equal the square root of 3, or x must equal negative the square root of 3. Do we all understand why ma'am says square root 3 or negative square root 3? Yes, I'm happy to explain if we don't know why. All right, Desmarie. Let's say, for instance, I've got, if I said x squared minus 9 is equal to 0. If I had said to you, solve for x, you're going to open 2 brackets for me, and you're going to go x minus 3, x plus 3. Agreed? And therefore, my answer would be x is equal to 3, or x is equal to -3. All right, let me do it the other way. Let's do it the way Abu did it. If I take my -9 and I take it over to the other side, I'm going to end up with x squared is equal to 9. In order to solve for x squared, I'm going to take the square root and the square root. Now, x is going to equal to the square root of 9 is 3. Or also -3, because I know 3 squared is equal to 9, and -3 all squared is also equal to +9. So I should get 2 answers. I should get 2 answers. Do you see what I mean? Okay, it can't just be the one answer. Both answers are valid. So when we take the square root of a number, we must always get the plus and the minus of that number, because 2 squared is equal to 4 and -2 all squared is also equal to 4. Both of those give me 4 as an answer. So when I take the square root, I must take the positive and the negative of that answer. Okay.